Hello and welcome to Codeblaze, and continuing on with the series Color Dash, a code overview. In this episode, we'll be going over how the game rules have been implemented. So, just to give you a perspective, I'll just start the game. And what I meant by game rules is basically controlling the speed of the game. So, speed here stands for the movement speed of the player and the surrounding objects. So, whenever I touch something that's different than the color, so my speed decreases. If I touch something that's the same color, the speed increases as well as the score. So basically handling all that comes under the game rules category, and this is mostly done using UniRX because it makes it simple to do, because and you'll get to know why. So let's just dive into the code. So before I do that, I just need to get few terminologies cleared on how this system has been implemented. So I have one thing called as connected speed. This is basically the global speed. So the idea is as time passes, the speed increases. Similar like you might have seen in Temple Run. So the global speed at particular point of time is denoted by this connected speed, and this is used by anything that wants to move according to this. So the main reason I have this is used by the players as well as the guards, so that they feel stationary because they are moving at the same speed as the global speed. Okay, so this all is handled by this speed manager, and ignore these red lines. I don't know why Rider is behaving a little weird. So what I have here is a configuration object that we saw in the previous episode, and that's how I get my default values. And what I use here is these float reactor properties. Now this is something that is provided by UniRX. So basically it is like I can have things subscribing to changes on these properties, and whenever I change the value of these properties, those things will be notified. And that's pretty much what I wanted here. So whenever I change my speed value in this component, and if I have other things subscribed to the speed value, they'll be notified of the change in the speed so they can take action. And the way I do this is using this observable interval. So what this does is it basically it triggers the subscription after the time interval that I have specified. It's pretty much like the invoke repeating you have in Unity, but this is the observable, the UniRX way of doing it. So first I subscribe to the game state signal. This is something that I'll cover in a later video, but basically tells me whether which state the game is in the play, end, or the restart. So there are a few states there, but in this video we'll be concentrating on the play state only. So once the game is on the play state, I set the connected speed value and the gravity scale to default. Now the gravity scale doesn't change anytime throughout the game. I earlier had the idea of changing it, but then I removed it. So this doesn't change, it doesn't matter, and it need not be a reactive property. But other than that, the thing I do here is start my interval, which runs in a time interval that I specify, and every time it basically increases the speed value of the connected speed. And then I have two and few components. So you can see this is the connected movement component. So I can add this to any game object, and that game object will then start moving according to the connected speed that is globally defined. So what I do here is basically get the speed manager using injection, and I subscribe to that reactor property, and I set it as the local, like I store that connected speed here in the float, and on the fix update I perform the translation towards the right. So this component is used by the guards, as you can see here. So that way if I play the game and see the scene view, start it and go to the scene view, and I focus on the guards. Yep. As you can see, they start moving along, and that's basically what the connected movement component is doing. So I can add it to any game object that I need to move along with the global speed. So it's pretty much simple. The other thing that I have is the local connected movement component. So what difference this has, it maintains a local speed. Now the local speed may be same as the global speed and may not be. So this is what is used by the player. since the player's speed may be reduced and increased. He may even go faster than the global speed at some cases. So for that, I use this local speed, the local movement component. So this also basically stores the connected speed in a variable, but whenever the connected speed is updated, it calculates the difference between the old and the new connected speed, and that's how it updates the local speed. And this local speed is then used to do the translation in the fixed update. Now this local speed can be reduced and increased from outside also. So the my player component basically calls these two methods to reduce and increase the speed depending upon which color is touching. So that's how the game rules have been implemented. Now detecting which color is touching happens in the player component, and it's pretty simple. Again, a few UniRX features are used here. So UniRX provides you things called triggers, and triggers can be used for any of the Unity related events. So you can have on start triggers, on update triggers, the collision triggers, okay, and that come in really handy since if you see the player object, it has two sub objects, the visual and the camera target. Okay, so the camera target is the object that I have put in the Cinemachine to follow, and the visual is the object that basically has the sprite and everything. Now the way I have these two as separate, because the rotation that I apply on the rectangle is only applied on the visual object, and it does not get applied on the transform that the Cinemachine is basically following. Because earlier I had them as the same, and there were some weird jitters with Cinemachine when rotation was happening, but separating them like this, those jitters are not coming because Cinemachine now doesn't. For Cinemachine, there is no change in rotation, to simply put it. So what I do is I basically get these two objects as serialized field, the transforms of those, and then I get some components in start. Yeah, so I basically get some box colliders and rigid bodies using the get component of those transforms, and I then set up my observers. And here is where the triggers come in. So I can use something like on collision enter 2D as an observable. So basically any Unity event, if I use the similar trigger for that, it will return me an observable for that Unity event. Okay, so this comes in very handy. Now I don't need to create a separate component on the visual box, the child object, just to get the on collision enter events. So this makes it like it reduces the code a lot, and that is what I'm using here. So on collision enter 2D, on collision exit 2D, and I have some operators applied. So the first thing whenever collision happens is the first thing I do is if any rotation is happening on the square, I dispose that, and then I check whether the other thing that I have collided with is a platform or not. If it's a platform, then only this platform collision subscription takes place, which basically gets the component, the color eye platform component from the collision object, and I get the color and I match the color, and I see whether the color is same or not. If the color is same, if the current color is the same as the platform color, I increase the score. Okay, so it's basically updating the UI and nothing special is in here. Yeah, though it's using one thing that I'll go over is this increase score. So if I open it, now I'm using something called as what UniRX provides is reactive binding to UI. So what you can do is subscribe to text. So whenever I update this value of this text, it automatically gets updated into the UI. I don't need to update the UI myself. So this is basically like data binding in many other frameworks you have, like in Android and JavaScript. But that's what UniRX provides here. Like it makes very easy to work with UI also. There are many more utilities for that. But that's something out of the scope of this episode. So the main thing that we have here is the rule handle. Now, depending upon this condition, whether it is the color is same or not, I have two different rules: the positive rule and the negative rule. So positive rule is something that's in favor of you. The negative rule is something that's not in favor of you. So what the positive rule does is, like if you are matching the color, it starts another repeating subscription, and it increases your speed. Now it will increase your speed only if your position is less than halfway through the screen. Like, you shouldn't increase your speed infinitely, then you may go off the screen. But if your position is less than from the half point of the screen, it will increase your speed so that you can gain up the difference. And this is done using that increase local speed variable. Now if the negative rule, we have the similar repeating event, and this reduces the speed. Now what happens on collision exit is pretty simple. I first check whether my position is more than the halfway point of the screen. If it is, then I basically connect the speed. I just say that the local speed should now be same as the global speed, so that way the movement will be pretty much the same. And if it's not, then you can just keep on increasing since you are not there. And I basically then dispose of the rule handle also, because I don't want these repeating subscriptions to be active. And that's basically how all the rule of this game has been implemented, the main game rules. And other than that, there isn't much. The only thing left to cover in this project overview would be how the game state is managed and how I have implemented the Unity monetization packages. And there would be one more episode on my final thoughts of using UniRX and ZenJet. So please do subscribe and leave a like, and if you have any comments or feedback or ratings regarding the project, or even how I deliver this information, please leave them down below. I've finally gotten some free time, and I'm trying to put in more and more effort in the channel, and I really want to improve the channel. I think this can be something really great. And also recently I participated in a game jam, the Game Dev TV game jam, and you can check out my submission there also. I'll leave a link down below. So thanks for watching. Bye.